Alright, hello again everybody. Welcome to lesson 5B, chapter 5.3 in the textbook, Common Factoring. So last lesson we talked about expanding. And what is expanding again? Well, expanding is simply getting rid of brackets, right? So for example, if I had x minus 2 or let's just make it simple, and an x. So if I were to expand this, I want to get rid of the brackets so it gets multiplied with every term on the inside. So thinking back to the exponent rules, x times x is x squared, x minus 2 is negative 2x. Now for the next 3-4 lessons, we'll be talking about something called factoring. Okay, a very important skills, and it's one of the number one complaints I hear from grade 11 and 12 teachers, myself included, that factoring is a skill that shows up so often, but a lot of students either forget or struggle with it in the later years, and that causes a lot of silly mistakes. So again, I don't mean to scare you, but it is a very important skill to perfect, and it's not difficult either. So what is factoring? Well, when we go from here to here, this is what we call expanding, getting rid of brackets, right? Expand. Now, just like adding is the opposite of subtracting, multiplying is the opposite of dividing, factoring is the opposite of expanding. Okay? In other words, we are trying to get it into bracket form now. Now, why would we want to do that? Well, the number one reason, to get from standard form to factored form. It's no coincidence that this is called factoring, and once it's in brackets, it's called factored form. So, let's go. Common factoring. So common factoring, this is the easiest type of factoring. Common factoring is simply, as the name implies, looking at each term and seeing what is common. Okay? So, first let's look at the numbers, the coefficients. Okay, so 15 and 25. What is the biggest number I can divide out of 15 and 25? It is indeed 5. Okay? So once I factor out the 5, I gotta ask myself, okay, well, what's left over? Well, 15 divided by 5 is 3. Okay? And then a w is still there. Don't forget about the w. Plus 25 divided by 5 is 5. 5z. Now, I look at this and I see, is there still anything common between these two terms? No, so I know I'm done. If you want to check your work, you can expand it and go backwards. So 5 times 3 is 15, so 15w. 5 times 5 is 25, 25z, which will give us what we started off with. Okay, let's look at the second one. 3, 6, and 9. What's the biggest number I can factor out of all three of those? A 3. Now let's look at the variables. 5 ends there, n times n times n times n times n. 2 ends there, and a single n there. So what is the most amount of n's I can divide out of each one? And the hint here is, look for the lowest one. Well, obviously I can take 5 n's out, but then could I take 5 n's out of 2 of them? No. So I could take 2 n's out, but can I take 2 n's out of the 1? No. So the most amount of n's I can take out from each term is a single one. So instead of, 3 divided by 3 is 1, and then I had 5 of them. So I factored out, or I divided out 1, so I should only have 4 of them left. Okay? And thinking back to exponent rules, n to the exponent 5 divided by n to the exponent 1 is 5 minus 1 is 4, so n to the exponent 4. Okay? 6 divided by 3 is 2. N squared, I took out one single n, so I just have 1 left. And last but not least, at 9 divided by 3 is negative 3. And then I have 1 n, I took that 1 n out, I am done. Okay? Let's look at this last one. So sorry, I kind of overlapped it, but I'll just do it down here. 4, 2, and 16. What is the biggest number I can take out of all three of those? A 2. Okay. Now, let's look at the variable x. So I have two x's there, 1 there, and 3 there. What's the most amount of x's I can take out? A single x. Okay? Because there's 2 there, there's 1 there, and there's 3 there. So I can take 1 out of each. I can't take 2 out of each because I can take 2 there, but can I take 2 out of a single one? No. And then last but not least are y's. So I have 2 y's there, 6 y's there, and 4 y's there. And what's the most amount of y's I can common factor or take out of each term? A y squared. Okay? So what are we left with in the bracket? 4 divided by 2 is 2. X squared, I have 2 of them. I took out 1. I only have 1 left over. Y squared, I took out both y squares, so I have no more y's from the first term. First term is done. Let's look at the second term. Plus 2 divided by 2, that's just 1. X, I took out the single x, so that's gone. I have 6 y's, and I took out 2 of them, so I have 4 of them left. And last but not least, 16 divided by 2 is 8. I have 3 x's, I took out a single one, I'm at x squared. I have 4 y's, I took out 2, I have 2 left. And I'm done. Okay? Common factoring. Now, factoring by grouping. It is still the same idea as common factoring. There's something slightly different though. So if I look at these 4 terms, okay, and I will use colors here to help. 1, 2, 3, 4. Do I see anything that's common in all 4 of them? No. But I do notice that this group has similarities and this group has similarities. Okay? That is why it's called factoring by grouping. It's still common factoring, but just by grouping. So how does this work? Well, looking at these 2 terms, what can I factor out of both of those? An m. Okay? Now, if I factor out an m, what am I left with? Well, mx, I took out the m, so it's just an x left, right? Plus my, if I factor out an m, what am I left with? Just an x. Okay? So that part is done. So I can almost ignore this whole side right now. Let's just focus on this other side. Let's go back to the red. 2x plus 2y. What can I factor out of those 2? Just the 2. Okay? Now, if I look at this, what is left over inside my bracket? Well, if I factor out of the 2 out of the 2x, I just have an x. If I factor a 2 out of the 2y, I just have a y. Now, pay attention to the colors. What do you notice? Well, if I look at this whole thing as one term, and I look at this whole thing as another term, I have 2 whole terms, right? I have 2 terms here. 1, 2. Now, out of those 2 terms, I'm going to ask myself, what is common in both of them? What do both of these green circles have in common? They both have, you got it, the blue x plus y. Okay? So I have factored it out of both of them. Well, since they both have x plus y, okay, then what is left over? Well, what is left over is just simply all the red stuff. Because if I took out an x plus y from this orange bubble, I'm just left with an m. If I took out an x plus y from this, did I say orange? Sorry, green. If I take the x plus y out of this green bubble, I'm just left with the plus 2. And I'm done. 2 sets of brackets. Okay? Now, a lot of this work, instead of me just copying it from the textbook, it's going to be, you're going to do it from the textbook. Okay? So, questions 3 to 6. All of them, because it will take practice. On page 234, let me just open it up so you can see it. Why is this not loading? Oh, that's why. Okay. So questions 3, 4, 5, and 6. Okay, so you're going to factor common factor. These ones are by grouping. Okay, now 5 might throw you off a little bit, but if I do this, it might help. Sorry. Okay, so remember, looking back at our sheet, remember the blue? Sorry, computer's lagging a little bit. So remember the blue x plus y's? Well, these questions just made your life a little bit easy. Because you look at this, x plus 8, and there's an x plus 8 in both, right? Which means that why won't it let me change colors? There we go. That means if I take a look at my 2 green bubbles, or my 2 terms, well, what is my answer? The answer is simply this. This equals 2. Well, there's an x plus 8 in both of those green bubbles, x plus 8. Okay. And then what's left over? Well, what's left over is simply the 3x plus 5. 3x plus 5. Done. I'll even do this one for you. So this one, now I got to be careful. Are these two the exact same? No. So in fact, I can't factor this one as of yet. Okay. So this one, no go. Okay. Let's take a look at this one. R plus U, R plus U. Could I factor that? Yep. So I know it's going to be an R plus U. And then what's left over? 4s minus t. 4s minus t. Okay? So these, question 5, I pretty much did it all for you. They already kind of grouped it for you. Okay? Whereas number 6, not so much. So I already did A. Let me do C for you. So if you looked at C and just focused on this part, okay, what's common in both? Well, I see an A in both. Okay? I also see a Y in both. I see an A and a Y. Now what's left over in this first term? Well, I took out an A and I took out one Y, so I'm left with just a single Y. Here, I took out an A and a Y, so I'm just left with Y plus 3. Okay? Now let's look at the second half. What can I take out of both of those? I think just a 4, right? If I took out a 4 out of this, I get just the Y. If I took out a 4 out of that, 12 divided by 4 is plus 3. Now if you notice, once you get a situation where these two are the same, okay, take a look at the 2 terms you got. There's one, there's another. Well, what's your final answer? That's just, you know, y plus 3 is common in both, and then what's left over? ay plus 4. Okay. Again, any other questions, please post in math questions and I will answer with a quick video. Okay? Alright.